Welcome to this explainer where I am literally pulling back the curtain to show you exactly, and I mean exactly, how examiners view your Cambridge AS and A-level mathematics scripts. I want you to picture this right now. It's late May, the rest of the world is asleep, my desk is illuminated only by the harsh glow of my dual monitors. On the main screen, the Cambridge marking portal is loaded up and staring back at me. Up in the top right corner, there's a live digital counter. It reads, scripts marked today, 142. And right below that, my mark verification meter is hovering at a very cautious 85%. I am your chief examiner, and today, you are stepping directly into my point of view. We are going to completely deconstruct the 1.6 series, specifically the binomial expansion of a plus b all to the power of n for a positive integer n. Now, you might be thinking, oh, I know how to use the formula booklet. But listen to me. This topic is not just a frequent guest. It appears in absolutely every single examination series, without fail. It is a high-tariff battleground where those coveted top-tier grades are either forged in the fire or completely forfeited. As a veteran examiner, my job isn't to just tick boxes. I am looking directly for your assessment objectives. I'm hunting for AO1, your baseline knowledge. I'm scanning for AO2, your ability to actually apply that knowledge. And I am desperately searching for AO3, that higher-order complex problem-solving magic. Over the next chunk of time, I'm going to show you the exact split-second moments an answer climbs into those top-tier marking bands and the precise, honestly heartbreaking missteps that cause a script to drop straight into the failing thresholds. Okay, let's take a super quick look at our structured playbook for today. We're going to hit the examiner's perspective, look at the core theoretical principles, dive into the method mark strategy, cover some massive examiner warnings, walk through our infallible solving framework, and finish up with how to secure those absolute top exam marks. Let's get right into it. Section 1. The examiner's perspective. Let's officially unlock the marking desk and see what's actually happening behind the scenes. Look closely at this quote from the principal examiner reports. It brilliantly, and I mean brilliantly, illustrates the divide between a passing grade and a top-tier score, transferable to unfamiliar contexts. When a high-tariff past paper question flashes onto my marking interface, you have to understand, I do not read it like a novel, I scan it. I have a 15-second window where my brain is subconsciously categorizing your entire mathematical ability based on your structure. Let's look at two typical candidate profiles I see literally every single day. I call the first one Student Alpha. Let's call him Alex. Now, Alex dumps these massive, unorganized paragraphs of algebraic steps onto the page. There's no flow, there's no clear substitution, just a frantic, stressful explosion of textbook coefficients and factorials everywhere. I have to desperately hunt for his analysis. Then on the flip side, there is Student Beta. We'll call her Sam. Now, Sam writes with beautiful, elegant flair. She lays out the formula perfectly, her handwriting is pristine, but she dances completely around the core command word. If the question specifically asks her to, say, evaluate the term independent of x, she might just blindly expand the whole entire bracket and stop, never actually answering the specific prompt. Both of these students are bleeding marks. Why? Because we, the examiners, are desperately searching for your ability to apply these core concepts to completely unfamiliar contexts. We're asking ourselves, are you just reciting the n choose r formula from memory, or are you actually adapting it to the problem in front of you? The exact structural choice that signals to me that a student is operating at an A or A star tier versus a C or D tier is when they explicitly write out their general term and instantly set up a targeted equation to isolate the unknown variable. That's the gold standard. All right, moving right along to Section 2, Core Theoretical Principles. This is where we start building your mathematical architecture. Now, what's really fascinating about this breakdown is that the reports explicitly highlight that candidates who reference causal relationships and cross-topic integration are the ones walking away with the significantly higher marks. Let's bring back our two prototypical students, Alex and Sam. I want you to imagine a live split-screen recording of them right now, actively debating how to write a model response to a classic high-tariff Cambridge question. The question is this. Find the coefficient of x cubed in the expansion of 2 minus x all to the power of 5 multiplied by 1 plus 3x all to the power of 6. Now, Alex, our chaotic worker, is relying entirely on that first row you see, precise definitions. He absolutely insists on listing out the entire binomial expansion of both brackets line by agonizing line, just to establish his baseline competency. He thinks volume equals marks, but Sam pushes back hard. She argues that without an evaluative, targeted link, the examiner is going to penalize their script for a lack of critical depth. Plus, she rightly points out that if they spend 10 minutes expanding both brackets entirely, they are going to severely run out of time for the rest of the paper. So Sam leans into the causal relationships. She argues they only need specific terms. The constant, the x squared, and the x cubed terms from each expansion, and they just need to pair them up logically to make an x cubed in the end. They start writing this down, bouncing ideas back and forth, under a strict time crunch. But here is where it gets real. Alex forgets to encapsulate the negative sign with the x in that first bracket. He treats it as a positive x. That is a fatal error. Sam catches it immediately, reminding him that the b term in the formula a plus b to the power of n literally includes the sign. It has to be negative x. That catch, that targeted evaluation and correction, perfectly demonstrates the transition from a messy, intermediate band response to flawless, top-tier execution. Which brings us to Section 3, the method mark strategy. Let's transition to one of the absolutely most critical aspects of exam survival, scoring your process. Timeout. Just push back from the desk for a second. Before I grade this final model paragraph from Alex and Sam and show you the devastating mistake that costs thousands of candidates their A-star, let's secure your own academic trajectory. Hit the subscribe button for Ace the Exams right now and turn on all notifications. Whether you're sitting for IGCSE O-levels, AS, or A-levels, this channel is your direct, unfiltered pipeline to outsmarting the marking desk. Seriously, join us. Okay, let's get back to the script. So the crucial point of the method mark strategy is that you must painstakingly deconstruct the question, extract the relevant data, and explicitly show your analytical framework with clear notation to secure these vital method marks. Let's look back at Alex and Sam. They hit a logical roadblock mid-argument. They've successfully isolated their x-cubed pairings from the two expansions. But when they are multiplying the coefficients together at the very end, Alex accidentally writes 3 times 4 equals 16 instead of 12. It's just a simple, silly arithmetic panic under pressure. We see it all the time. Now here's the kicker. If Alex just scribbles the final incorrect answer of 16 at the very bottom of the page with no working, I, as the examiner, have absolutely no choice. I have to give him a big fat 0 for that section. But because Alex deployed a strict mathematical progression, he showed his formula, his substitution, and his simplification. The whole outcome changes. He explicitly wrote down the combinations they were multiplying, like 5 choose 1 times 6 choose 2, and he actually showed the unsimplified numbers before making his arithmetic error. Because I can see that logical string, my digital grading pen clicks and I award him the method mark, an M1, even though the final accuracy mark, the A1, is lost. That is exactly literally how you salvage a script that is teetering on the edge of a lower grade. Let's move into Section 4, the top 3 examiner warnings. As a veteran, I see the same things every year, so let's make sure you are avoiding these common traps. Now, I am going to hand the digital grading pen right over to you for a live marking audit. Consider this your 30-second data scan challenge. Look at these 3 exact mistakes pulled directly from the principal examiner reports. I'm starting a mental 60-second visual countdown right now. I want you to extract the single highest yielding trend here. Got it? It's the 3rd bullet point. Generic application is the absolute fastest way to drop into a failing threshold. What does a generic response actually look like in high-level mathematics? Well, it means a candidate writes down the formula for the general term of a binomial expansion. They write out n choose r times a to the power of n minus r times b to the power of r, but then they just leave a, b, and n as abstract variables, instead of actually substituting the specific values from the question, like 2x and -3. Listen to me, examiners demand specific details. We literally cannot give you marks for just copying out the formula booklet. That proves nothing. We give you marks for actively substituting your given values and deploying them to solve a problem. Okay, challenge 2 in our live marking audit. Spot the penalty. We're looking at a deeply flawed sample student approach on the left versus a flawless one on the right. The classic penalty occurs right here on the left side when a student relies on descriptive fluff. Imagine I'm reading a script and the candidate has literally written, I will expand the brackets and find the terms with X. Are you kidding me? As an examiner, my digital red marker heavily slashes through that approach. It forfeits critical marks immediately because it lacks any semblance of analytical rigor. You must always strive for the right side by linking every single analytical point directly to the given exam scenario. Instead of that vague nonsense, you need to write out mathematically. To determine the term independent of x in the expansion of x squared minus 1 over x, all to the power of 12, I will equate the power of x in the general term to 0. Therefore, 24 minus 3r equals 0. Boom, done. That is context-specific integration. That pristine mathematical progression just secured you 3 method marks in a single elegant step. This right here, this is the exact moment where a student leaves the average pack behind and rises to the top of the class. Section 5. Deconstruct, solve, and evaluate. This is your infallible framework. Let's lock it in. To prevent all those penalties we just talked about, we utilize a strict procedural framework. I like to think of it as mathematical peel. Point, evidence, evaluation, link, but adapted for numbers. Whenever you tackle a complex series question, follow this exact step-by-step procedure to guarantee you are capturing every single available method mark. Step 1. Identify the given information. Extract the A, extract the B, extract the N, and write them down clearly. Step 2. Break it into logical steps. Ask yourself, what is the core command? Are you looking for a specific coefficient, an independent term, or maybe an estimation using the first 3 terms? Define the mission. Step 3. Solve systematically. This is where you lay down your combinations and your indices rules with absolutely ruthless precision, no skipping steps. Step 4. Check for reasonableness. Evaluate your own work. Did you just calculate a negative factorial? Did you get a fraction for r when we all know r must be a positive integer? If so, you've made a mistake. Catch it before I do. Finally, step 5. Make justified recommendations, which in pure math simply means clearly stating your final deduced value with absolute clarity. Applying this infallible framework guarantees your logic is completely airtight, your arithmetic is double-checked, and your mathematical sequence is just pristine.
We made it to the end. Section 6, Securing Top Exam Marks. Let's look at the strict conventions and the final polish that guarantees success.
Let's picture Alex and Sam one last time. They've assembled their completed, flawless response paragraph using everything we've discussed. I look at it on my screen and I happily enter a perfect, full-mark score into the Cambridge system. It is so satisfying to do that. Let's distill this entire session into 3 universal marking truths. First, the 15-second structure scan. Your work must be so cleanly structured, utilizing proper headings and spacing, that I can instantly see your logical path, from the very first substitution all the way down to the final answer. Second, the mark per minute velocity rule. You must deploy correct mathematical terminology efficiently. Don't write essays. Use terms like coefficient or independent term to save time and secure marks. And third, the final quality review pass. You must provide clear annotation for every major logical leap. If you are substituting an identity or using the laws of indices to simplify x squared raised to the power of 3, show me that intermediate step. It explicitly tells me, the examiner, that you aren't just guessing. You're demonstrating profound, undeniable mastery of the subject matter, leaving me absolutely no choice but to award full marks.
So before you walk into your next exam, I want you to ask yourself this one critical question. Are your binomial expansions truly specific to the exact context of the question? Mastering this method mark strategy, understanding exactly what I am looking for when I open your script, is your direct ticket to outsmarting the marking desk. We've pulled back the curtain today. The desk is now yours. I want you to subscribe to Ace the Exams, click the notification bell for our weekly examiner breakdowns, and right now, leave a comment below stating your subject, your qualification level, and your current target grade. Put it out there into the universe. Because the question is, the next time that 15-second timer starts ticking on your script, what will the examiner see?